Hello, hello, can you hear me? Hello, students. Uh, we are going to solve today the sample paper which has been given to you all. So I'm first sharing the sample paper, and then we are going to solve the problems one by one. Okay, so let's see. I'm showing you. Here is the sample paper. Okay, now this is the sample paper. All right. Now this is the sample paper, and now I'm going to first, the very first question is what is RAM and the difference between RAM and ROM. Okay, now this one is quite a simple one. Let me close few other tabs which are not required. Okay, so the RAM, RAM is basically random access memory. Okay, random access memory is the RAM. Okay, this is the random access memory, and you know it's basically is the it holds all the it holds all the data. Uh, it holds all the processing data. Okay. Rather, we can say it's a temporary data. Now, if we say in terms of the question is saying like here it is saying what is the difference between RAM and ROM. Now, if you come to the difference, so basically, you know, RAM is a volatile memory, and it's slightly bigger in size. Okay, its size is bigger. Okay, comparatively bigger than the ROM. Okay, so and you know the types like SRAM and DRAM, which are the different types. Now we come to the next one, which is a ROM. Now, what is ROM? Now, you know, ROM stands for read-only memory, and it's basically stores, it holds permanent data, okay, permanent data, as this data is here, and it is non-volatile, okay, and also it is smaller in size, and there are different types of ROMs are there, like you have a PROM is there, programmable ROM, then EPROM is there. Okay, so this is what is there. This is a quite a simple one. You can easily understand this one. Okay, this is the first A. Okay, now we come to the next one, which is the B. Okay, so the question number B is saying, what is the system software? You know, system software means very simple. It's these are the software which are basically meant for the purpose of functioning of hardware and software. Okay, so these are the softwares. These are the softwares or programs. Okay, programs uh, which uh, are meant for the purpose of functioning of hardware and software. Even I would say it's both function, but basically these are the software which enables you to work with the uh, hardware and software. And the common system software here are your operating system. Okay, operating system are there. Your language compilers are there. Translators are there, like your interpreters and compilers. Your device drivers are there. So drivers are there. Okay, now we come to question number 3, C part. Now C is a function of operating system. See, operating system functions are, when we see the functions of system, basically the very first thing it comes to anyone's mind, it act as an interface between hardware and software. Okay, so you cannot use your hardware and software without operating system being present. Okay, so it's very important. Secondly, the other things which it can does, it is the process management. Okay, process management is basically an activity where you create process. Okay, so whenever you are clicking on something, it's running process, then deleting, all this comes under process management. Then the next very important thing is the memory management. Memory management is whenever a program is running, it need to be allocated memory and deallocated. Okay, so then we have a file management. So file management is also, there you have a Windows Explorer is there. You have seen also it's a file is there, which is you can see. Then you have a device management. Device management is about all the input output devices which are connected to your systems. Okay, and even operating system helps in security and sharing of data. Okay, so this is about C. Now we come to the D. Okay, so you can go through this thing. These are basic topics are there. You can a little bit elaborate and you can write. Now the next one is your, okay, so the number is FAB in 16. Okay, so you have to convert it. Let me open the another version of this one so that I can copy the text from here for you. Okay, so just give me a minute. So okay, this paper is here. Now I am coming to this one. Okay, FAB in 16. Okay, this two. So you need to convert this is in first one in hexadecimal and second one in octal. Okay, now remember it's a very simple rule you should follow is okay, let me write first, write UFAB. Okay, I need to bring the old formatting here, so I'm putting it here and doing it here. Okay, so let's see, this is FAB. Okay, now see, whenever you have anything is in 16 bits. Okay, not 16 bits, in a hexadecimal, you can convert it. You have in this program you have to convert, in this question you have to convert the number into binary number. So it's very simple. Remember you have to, this is nothing but it's 15, this is 10 in hexadecimal, and this is 11. Now if you do this one, it is 111. Okay, 10 means 1010, and a very simple rule you can remember. Okay, this is like you can do is 8421. So in case like I want to do this is 8 and 2, and 11 means here 1011. Okay, this is 11. Okay, so just the entire thing if you write it here. Okay, so this FAB is, so you can get this is the answer. Okay, so this one is the answer. You can write this thing 111, then 1010 and 1011. Okay, now this is the one. Now what about the second one, which is 403 3.25? Okay, now this is an octal. Now for octal, what you need to do is that you have to give a gap. Okay, and this time it is of 3 bits. So for making it a 3 bits, you have to do this thing. So 4 will be, okay, if I come to here, 4 will be what? It is 100. 0 is 00, and your 3. Okay, now 3, little bit I'm shifting here so that it will be easier to see. And 3 will be 011. And then dot is there, 2 is 010, and 5 is 101. Okay, so this is just you write the same thing, it is becoming the answer of this one and this one. So this is just you have to write together. So this is the first one and this is the second one. Now we are coming to the E1. Okay, E. Now what is the E1 is saying? You have to okay, these are the two numbers are there, you have to convert it. Okay, so you have to convert this number, one in hexadecimal, the other in octal to decimal. Okay, now 132, if you see, okay, let me write 132 again. There is a formatting issue, so let me solve it first. Okay, 132 is there. So the procedure is very simple. If you want to do this thing, you have to divide it by 16. Okay, so if you divide it by 16, so this time you're getting 16.8. Okay, so 16.8 is 128, right? So 128 is there, and then your quotient is 4, correct? Remainder is 4, quotient is 8, and this. Then again, and now see, when you divide 8 by 16, this time your this will be 0 and this will be 8, correct? So the result of the first one, which is 132, 132 is equal to, and we go in reverse order, 84. Okay, 84 is what is the thing. Okay, all right. So this is the easier one which we have done. So one uh, okay, so we are getting this thing. Okay, just a minute, let me see. This thing is okay, we have to convert the 132. Okay, wait, 132. Okay, just a minute. Okay, yeah, it's okay, perfect. Okay, so I just verify it's okay. The correct now. This is the next one. This is a even simple one, which is 324 point 1. Okay, this is in octal. So octal, you know, it's very simple. It will be 4 into 8 to the power 0. That is, you can write this thing. Then you can write 2 into 8 to the power 1. Okay, and then you are getting this is actually, this is what, 3 into 8 to the power 8 to the power of 2. Okay, and this side it will be 1, so it is 1 uh, into 8 to the power of -1. Correct. So what we are getting here, this is 4, this is 16, and this is 64 into 3. Okay, 64 into 3. Correct. I need to do this thing, and then we are getting here this thing will be 1 by 8. Correct. So if you do this thing, so it is coming, you can see this one is very simple. This is 20, and then 64. This is means 12, and they are 18. So it's 192. 192 and 1 by 8 can be written as 0.125. So you are getting this thing here. So it is 2 here, 11 here, and 2 here. Okay, so point, and we can write this thing as a 0.125. Okay, 0.125. I think this is a easy one we have done. Now EF, now 55 in sign magnitude and in one's complement. Okay, so we have 55 here. So F, we have 55. Okay, and what we have to do, we have to do this thing in, okay, here in sign magnitude and in one's complement. So sign magnitude and one's complement. So first thing, before we come to the sign magnitude, the first thing is that we need to know what is the binary representation. Okay, there was a bit of network issue. Now it's solved. So if we come to so it is coming somewhere 11011. Okay, you can do it's very simple. Remember, it's 32, 32, 16, 8, 4, 2, 1. So you can say 16, 32, 32. You need here 16. This is 48, 48, and if you take 4 and this thing, and I think it's coming with. Okay, fine. Now in a sign magnitude, what we need to do, the sign magnitude, if you see sign magnitude, in sign magnitude, there are 8 bits. They are saying 8 bits. So the first bit is for the sign bit. Sign bit, first bit is the sign bit, and rest the remaining 7 bits for the magnitude. Okay. So what will be the answer here in this case? So in a sign magnitude, the first bit in this case will be for a positive number, it's 0, and the remaining, I can see it here, how many 6 are there? So 1 0 more here, and 1 1 0. Triple one is the answer. Okay. Now we come to the ones complement. Ones complement is basically is used for negative number representation, but as it is given here, but in ones complement, what we do, the number is just converted. Okay, if it is a negative number, I hope it's not given in this one. If it is a negative number, just only -1. Okay, so let me see. Let's we take change a little bit this portion. If it's a minus negative number, you have to do, because this part is done specially for the. Okay, now this is okay. So negative number. So once representation is, everything remains same, but you have to change 1 to 0, 0 to 1. So this is 1, then 20, then 1, and then 000. Okay, so this is done, I think. Okay, so we have done the question number 1. Now we come to the question number 2. Question number 2, part A. So De Morgan's law. De Morgan's law. Okay, there was a network issue. Now it's okay. All right. De Morgan's law. The first law is A plus B whole complement. If you do, it's equal to A complement dot B complement, and this is an easier one, so I won't go into the truth table one. And A is complement is equal to A complement plus B complement. I think this is done. Okay. Now we come to the B part. Okay, B part. B part is that draw the circuit diagram for this one. Okay, so you have you see these are the two one which circuit diagrams are there. So let me copy it and bring it here. Okay, circuit diagrams. So first one is like this is there. So you see here there is this one gate is there. There is a one gate. Remember there is a rule is there which is saying that first you have to put the not, then you are going to the and then you are going to the or. Okay, so on, but and the, obviously the brackets are. So if you do the first one, okay, let me see a b c a b b c and a. So let me see where I can do it's okay. So here I am having the gates. Okay, so the first one is my ab. So if I do it this one here, this and this is for. Okay, I can give a name here, I can label it. Okay, there's a naming thing is there. Oh no, its naming is not there. Uh, okay, let me see. There's any other things I can do. Oh yeah, text is there. I can annotate. So this is okay. So this is E, and if I take the another one, this is a B. Okay. Now the next is oh yeah, it's B, C, and A. So B, C, and A. So one time more, I'm taking one more. So this is for BC. Okay, this is B and this is C. Okay, so BC is there. So we can take this BC here. And so once again, I'm not labeling it. So this is B and there is another one which is C. Okay, C. So I got this one. Now we have a E. So E is just direct is there. So E, I'm taking it here. So for E, I don't see A is already present here. So I can take it A from here one separate. Okay. So yeah, I can take it from here. Okay. So that's very nice. So I'm getting AB1 I'm getting. Then I'm getting one. This is for BC. Okay. And then I'm getting for this one. Okay. Okay. Now I need a OR gate. Now this is a OR gate has come here. Let me put it here. Let's see if I can bring all of them to connect to this to this, and let's see if I can go connect this. Oh, it's worked fine. Okay, so a little bit bigger if I can. Oh, this is okay. Okay, this is the first part of the circuit. You can see this is A B B C, and then one more is A B C complement. Okay, so what I can do is here. So I need A here. I need B here. And if I can get, okay, this are two are there, and I need one more here. Let's see if possible to add. It's taking only two. Okay, can I add one more? Okay, let's say I take C from some other. Okay, so here this is A, this is A, this is B, and I need a C. So C I can take from here. Okay, so C is there. But in case of C, what what I need is the complement. Okay, so I need a complement here. Not gate. Okay, so not gate. I can take it from here and I put it here and I connect this one with this, and then I am putting it. Okay, so this is, oh, it's a bit of going. This is deleting it, and I'm putting this. Oh, that's looks perfect. Okay, so these two gate are there, and finally I need a AND gate. So I'm connecting this by this and this by this. Okay, so you can see this is how it is done. Okay, so let me. So this is done. Okay, here. So what we do is now we copy this one. Okay, so let's see, it has a copy tool is there. So let's see if it copy. Okay, I'm copying this one and let me paste it here. Okay, if it comes here. Oh, it does not come. Wait just a minute. Let me copy in another way. Okay, so I will copy this one here and put it here back to here. Okay, so this is the one is there, and similarly you can do this gate also. I've shown you one example. I think this is sufficient enough for this, and rest the second one is pretty much simpler. Okay, let's see, come to C. Now C is saying you need to this is the B plus C. You need to verify, name the law in the expression and verify. Now if you look at the law, this law is, which law is this one? Do you know this is the law? This is known as the distributive law. Okay, distributive law. And you need to do the if the truth table verification. I'm just telling you what is the truth table here. You need A B C 3, then you need B C 4, A plus B 5, then 6, then 7, then 8. Okay, so let me insert it here, a table with at least 8. Okay, and this side also I need a 9 except for the this. Okay, so here it will be A, this will be B, this will be C, this is BC, this is A plus BC. Here it is A plus B, this is B, A plus C, A plus C, and this one is final one. So this is A plus B and A plus C. Okay, so this is the one is there. So a little bit I bring it here so that the things will be there. Except the last one, I don't think we need that much space. Okay, everything looks fine. Okay, now you know it's very simple one, 0 0 0 and then 1 1 1 1. The next one will be 0 0 1 1 0 0 1 1. This one is again 0 1 0 1 0 1 and 0 1. Okay, all right. So BC, you can see 0 is there, 0 is there, 0 is there. Obviously, this is 1, then this is 0, then this is again 0, and this is again 0, and this is 1. Now, A plus BC. So A plus BC means wherever any 1 is there, you can just, in case of OR gate, you always look for 1. So this is 0, now this is 1, and rest is all 1 because A is 1. Now, what is A plus B? Again, here we see 0, 0, this is, oh, this is 0, this is 0, this is 1, this is 1, and rest are all 1. And A plus C, what is A plus C? You see it's a 0, this is 1, this is 0, this is 1, then rest is all 1. Now, if you do the AND gate, if any 0 is there, then 0, and rest all is 1. Oh, this is how come this 2 is 1 1 1. So this is a very simple way of doing a truth table. So it's, you can see here LHS is equal to RHS, hence proved. Okay, this is proved. This is that. Okay, so I'm coming to the next one, which is C. Now we come to the D part. Now the D part is saying you have to do the complement. Okay, so complement means, remember, it's a De Morgan's law. Okay, so if you do the complement one, okay, so how we do the complement one? So F if you do F complement, it will be E complement B plus C complement B plus A B C whole complement. So what it will be, you know, this is A plus B whole complement is equal to A complement dot B complement. So it's A complement dot, and this entire thing complement dot C complement B, this entire thing complement dot A B C, this whole complement. Now this can be further, now we can do, this is E plus B, you know, complement again. Then it is C plus, rather I write it's a B complement plus, oh, here E plus E complement is moved, this is B complement. This is B complement uh, plus C. Okay. And this is E complement plus B complement plus C complement. So this is the complement one. So this is, we have also done. Now we come to the E part. Now E part is prepare the truth table. Okay. So I think I don't think there is any need of truth table drawing now, because you have seen how it can be done. So please do it yourself. So DIY, do it yourself. Okay, now we come to the flow chart of Armstrong number. Okay, so you want a flow chart of Armstrong number. So I'm showing you how to draw a flow chart. Okay, this is flow chart of our Armstrong number. Now, F, it's for flow chart of the Armstrong number. This is the draw. Okay, so flow chart. Okay, let's but before with the flow chart, like Armstrong number, you must know what is the Armstrong number. See, Armstrong number, our number like 153, we can say Armstrong number. This is 1 cube, 1 to the power of 3 plus 5 to the power of 3 plus 3 to the power of 3. Okay, so you know, this is a sum of the, see, we first here what we have to do, we have to read the number, we have to read the number n, then we have to find the count of its digits. Okay, then we find the, then we have to do the sum of the sum of each digit to the power of its count of digit, count of power of count of digits. Okay, now we check if n is equal to the sum, then we say, if this is the condition, then we can say it's Armstrong number, Armstrong number, else it is not, else it is not an Armstrong number, Armstrong number. Now this is the basic logic which I'm going to put it in the this thing in the flow chart. Okay, now here's the flow chart one. So we take the first, we have to, okay, here we take the let me see this one. So here we will write a number. So input n, we the input n. So you read n, whatever the n value is there. Okay, I can push it back a little here. Oh, it's okay, fine. After reading that, oh, this box is slightly, I need to change it. I think this box will not work. This is a okay, let me delete it and add it. This is also, so one time more, I'm just starting this thing, and this is the input box. Okay, this is just there, but let's see, we follow the correct one. Read n. So you read the n. Once you read the n, then what you need to do is you have to find the you have to see, the very first thing, you have to convert this number into a string. Okay, so okay, let me this thing. Okay, so it's a kind of a process. It's a very simple one. So let's see, Sn is equal to, so Sn is equal to str of n. So this is the code specific I'm writing it. So convert into string. Once it's converted to string, the next thing I need to find the length. Okay, so so here, okay, okay, so let's see, length will be L. Okay, L is equal to len of Sn. This is the string. Okay, now I have to take a for loop. Okay, so using a for loop, we can do this thing. So here, Let me check. Okay, where I can. This is slightly. I've taken a lot of distance, but no problem. We take a for loop here only. Okay, so a kind of for loop we can do it here only. So here, okay, so this much is there. So for loop will be here for I in uh, we read all the digits one by one, but here we are reading the string values. So range, so we can go it in any order. So we are getting this thing. So L, okay. And now after this, we need a kind of a connector sort of thing. Oh, it can go beyond also. That's okay. Okay, so let me see if I can do a connector here. Oh, connector is, let's see, this one is a connector. Which one we can take it? Okay, it's not there. Let's see. Uh, okay, it's possible. You can, here I can draw it. I can go downwards, but in case if you don't go downward, you can use a connector and go to the next side. Okay. So for range L, now what I need to do is I have to, oh, here one more thing which I need to add it here. Let me see if I have not added here. So that is sum is equal to 0. Okay, so then now I'm here coming and I am adding here one more thing, which is the uh, sum is equal to sum is equal plus equal to we have the power of this is the digit. Okay, so the digit is at the position of Sn at the I position, and this is to be converted to integer. Okay, integer we have to convert it, and to the power of the L len. Okay, so what is the len is there, so little bit if we can make it bigger. Okay, this is fine. I think this is okay. So we have converted this sum, we have got it. So this sum we keep on doing, and here then after then we will come to, okay, after this we need this box. Okay, so here what we do is that from here, if we can take a box, okay, this oh, let's see if I can take a line here. This is okay, if I, okay, let's see this line. Oh, it has changed this line only. Okay, I don't want this change, but let's see. If it I can send backwards, send to back, send bring forward. These are there. Let's see if, okay. Anyway, I draw here one more. It's if I can take a line from here. Let's see, which I can take. Flow chart is there. These lines are there. Oh, connectors and all this are here. Okay, so line is there. Okay, so I can take a line from here. Okay, okay. Then I bring it. Okay, then again I will follow this line here, and it will be okay, and then one time more. See, it's a bit of you can understand it's there in computer, but you can easily. So this is a kind of a loop thing. Okay, and then we come to your decision. Decision is this: if your sum, if the sum is equal to the value of n. Okay, so you can write this thing. So here if it is true, okay, then okay, no, you don't need this box. If it is true, then we can say this is a, okay, then we can say input output box. Yeah, so n is Armstrong number. Okay, Armstrong number. Print Armstrong. Okay, print Armstrong. And if it is, okay, if I see here if it is no, okay, so this is here. Oh, this thing is yes. Oh, if it is yes, sorry, this is how it's coming. This is this yes, yes, and if it is no, here this will come as not a Armstrong number, not Armstrong number. See, the I think the basic idea is clear to all of you how it can be done. Okay, so this is the basically how I have done this one. You can do also. Okay, so I'm not copying it, but I have shown you. I think this is good enough for you to understand how it can be done. Okay, this is done. All right. Now we have to write a program to check whether to check it is a right angle triangle or not. Okay, question number 3. So let's see if we can do. So let me put up on ng Python. Okay, let me start the Python compiler. Okay, this one. All right. So the question is saying that program to check whether the three sides and whether it's a right angle triangle or not. So there are different ways are there. So let's see. I'm taking the how to do this one. So we take the three sides, which is A comma B comma C, and we write this is eval equal to input, enter three sides, three sides. So you got the three sides. So once you got the three sides, then we have three conditions. First condition is your E to the power of 2 is equal to the sum of the, otherwise let's see, we do three results. One, t x is equal to E to the power of 2, y is equal to b to the power of b square. Okay, c is equal to z is equal to, and z is equal to what? C square. Now my first condition is that condition C1 is that your x, the if C1 is x is equal to the sum of y plus z. Okay, this is C2 is equal to yes. The question is saying you have to find this a right angle triangle. So you know one of the largest sides which is hypotenuse is equal to the base into base square plus height square. Okay, so this is this one. This will be y is equal to x plus z, and the third condition, which is uh, z z is equal to x plus y. Okay, now if any of the condition is true, like if C1 is true, okay, if C1 or C2 or C3, we can say print right angle triangle, right angle triangle, else we can say it is print not a right angle triangle. Okay, print not a right angle triangle, right angle triangle, triangle. Okay, so this is the second one. Okay, so this is the one. Okay, you want to run it. Okay, let's see. We know the very common one, 3, 5, comma 12, comma 13. Okay, so this is the right angle triangle. Yes, exactly. It's there. And let's run with something else like 4, comma 5, comma 6. Maybe triangle is also possible or not. We don't know, but this is the correct answer. So you can put it, the values here also directly, but let it be. So this is the third E. So we having the third E is this one. Now we are having the next one. Write the complete the syntax error. Okay, so we here, this is the one. So when I was seeing this problem here, I can see the first one is absolutely correct, second one is correct. Okay, Okay, so the next one is there was a bit of audio issue and we have completed that one. That was just I'm again telling you this. The only thing is that this string cannot be given some value like this. Okay, so it's a immutable. Rest of the thing I can see. Quadratic equations. Okay, so quadratic equation again you need three values. Okay, a b c, which is equal to eval, and then we write input, enter abc value. Okay, abc value. Once you get it, then you have to calculate d. D is b to the power b square minus 4ac, 4 into a into c. Okay, so now first, if you get the d value lesser than 0, then we can say print roots are not possible. Roots are not possible. Correct? Else. Okay, now we have to calculate the roots. Okay, so r1 is equal to minus b plus square root. Okay, so for square root we need import math. Okay, and we write math dot sqrt of the value of what d. Okay, now this entire thing, after doing this thing, we did 2 into a. I hope you people understand this one. Okay, and this is again we go here and it is r2. R2 will be only here, the minus will be there. Okay, here minus will be there, rest is the same. So we have got the roots are there. So print uh, here we write r1 is this root and print r2, this is the second root. Okay, now let's see which one we can see. Okay, let's say one equation we take x minus 3 and x minus 4. So this will be coming to somewhere x square, x to the power of 2, that is minus 7x if I'm right, and this is plus 12. So we are getting the value of x, y, a, b, c as 1, minus 7 and 12. So let me run it here. So it is 1, comma, minus 7, comma, 12. Okay. So this is something is there. So let's see what is answer. It's coming perfectly, minus 4 and 3. Okay. So this is also done. Okay. So up to this is the code. Okay. All right. So we have come to this part. Okay. So it's going well. Okay. So let's see. This is okay. Oh, it will be coming here. Okay. So here it is there. Okay. So we are this part is done. Okay, so we are coming to the next part, which is the d part. D. So what is the d is there? Open source language. Okay, open source language means, you know, open source. Source means the source code. So the reason open source language is the reason is language is why, because it is source code is available. Source code is available. Okay, it's freely available. Is freely available, and it can be modified. It can be modified and redistributed. Okay, so this also you can do this, redistribute it. Okay, so this is the one. Let's see, we come, oh, I move to the next line, next row below e. Okay, now e is what saying, is saying compiler and identifier. I think this is a very common one, so I am skipping this one, you know, but still if you want to know all lines translation together. Okay, and here debugging is very difficult, okay, and interpreter is line by line translation and execution of code, and obviously here debugging is easier. Okay, easy. So this much is done. Now we come to the F1. So F1 is saying which one is the identify the valid identifier and this thing. So if you want to identify the valid one, the first one is obviously it's invalid because you cannot have a number. Okay, as the first one. Invalid. True is a keyword, so it's a valid keyword. And if you ABC, it's a valid identifier, and this is also a has no problem, but it's looking like a function, but it's a valid identifier. Okay, it's not a so we have done this one. So we are now moving to question number which is question number 4. So question number 4 is saying, what is the significance of continuous statement? Explain with an example. Okay, so 4a. Okay, now what is continuous statement? Continuous, basically it is a jump statement. Okay, jump statement used in loops. Okay, what it does, it skips the remaining part of the loop, remaining part of the loop, uh, uh, part of the loop, and moves to the next iteration of the loop. Okay, let's see. I show you one good example by which you can understand. Let's see. We want to print only the even numbers. Okay, so let's see. We do want. So let's see. We have a loop for I in range of, let's say, 1 to uh, 1 to, let's see what, make it 20. Okay, 20, and then we write print I. Now it's going to print, if I give a space here, and this is going to print all the 1 to 20. Okay, 20 won't be coming, so 19. Okay, now I want to print only 2, 4, 6, this one. So one part is this: if whenever, if one way I can do, if I find the I mod 2 is equal to 1, that is a odd number, then I do continue. So in that case, what will happen? It will not execute this one. Okay, for odd number it is not going to print, but for even number it is going to print. Okay, so you see, this is how exactly it's done. So here I can see the output of this code. Output, if you look at the output, so output of the code is something like this. Output of the code is this one. So we write the output of the code here. So this is an example which can make you understand why this is example code is this one. Correct. So we are coming to the next one, which is the Krishnamurti number. Okay, Krishnamurti number is almost like a case of I can see it's like an Armstrong number. So instead of doing it here, sum of its like to the power, here it's a factorial of each one. Okay, so if we come to the B part, so this B part is the Krishnamurti number. Krishnamurti number. Okay, so and the one example is given also here, which is 145. So let's see. First, we read the number. Okay, let's see. Let me read the question here. Krishnamurti number, sum of the factorial, it's a number equal. Okay, so we read the number. So let's see, int input, enter number, you got the number. Then what you need to do is that you have to get. So again, we will follow the same thing here. Sn is equal to the string of the number. Okay, we have this flexibility. In other programming language, we have to do in a different way, but as we are capable of doing it here, let us do it here. Okay, so we got the length of the number, so which is len of the string. Okay, string. Then we go to the for I in range of L. So now we'll read each of the number. So let's see, x is equal to int of here the number is Sn. Okay, and it is at the position of the I. So the first number. And then what we have to need is the factorial. So factorial we need to is f. Oh, this is f. Factorial f is equal to 1. And for I, let's see, j in range. Factorial is always, we have to start from the 1 till the number. Okay, so here the number is like 4 x factorial. So it will be x plus 1. So x will be also there. And f is equal to f into j. Correct. So this is, we have got it. Now we need to hold the sum. So let's see, one sum variable, we put it here. Sum is equal to 0, and we write it here as sum plus equal to f. Okay, so this is the part we have done for the summation. Once this is done, okay, now once this is done, what is left is that we have to do the checking. So if the sum is equal to n, then we can write print n is Krishnamurti number, n is Krishnamurti number, Murti number. Okay, and else we can say print n is not Krishnamurti number, not Krishnamurti number. Okay, so let's see whether this is working or not. So let's see, we first start with 145. 145. Oh, 145 is Krishnamurti number, so I think it's work. Okay, let's see, run anything. 35, 34, it's not a Krishnamurti number. So you can do in this way. There is another way also there, but as Python gives a lot of flexibility, so we go by this one. So there's nothing wrong in doing this. Okay, so we are coming to the next one. Here is the output. Okay, so here is the output of this one. I need to find the output of this one. So I just show you how to you can do this thing. I will not execute the code here. This is the one here. This is the one here. This is the here, and this is here. Okay, now something like this. Okay, so here you see what is the value of a. A value will be anything between 0, 0, then 3 gap 3. Then we have after 3 what will become 6. After 6 will be 9. This is A. Okay, and your B value. So for A value we have a 0, then we have a 3, then it is 6, and then it is 9. Now here the B value will be now changing every time. Okay, so the B value. So B value will be first time. It is from 1 to A, that is 0. So obviously it is not going to 1 to 0, and the space 2. So it is, if A value is 0, it will not work here. Let me see, I have copied it correctly. Yeah, it's correct. This is print should be here. Okay, inside of the verse, it's not. Okay. So this is 1. So next one will be 3. So 1, 2, 3. So 1 after 1, the 2 if added, it's 3. So obviously 3 will not be counted here again. And so here only 1 will be printed, correct? Then next will be 1 to 6. So it is 1, then 2 will be added, 3, then 5. So obviously here 1 comma, you can see what things are there. Here you will get 1 comma 5. Oh, I need to write it 1 comma 3 comma 5. And if we come to the 9, so we are getting here 1 comma 3 comma 5 comma 7. Again 9 will not be there. 9 will be there, but it will not. So it will be 1 comma 3 comma 5 comma 7. Okay, so this is should be the case. Okay, so let me run it once. So you see first time nothing is printed, then 1, then 3, 5, 1, 3, 5, and 7. Okay, so this is the output of this one. So we have done this one. So the next code is we have done B. Now C is this one. C is this one. So this is the output. Okay, remember the first line will be blank. Then we come to the D. Okay, now D. Now D is kind of this figure. Okay, this star is there. 1. It is you see what kind of a value is 1, 3, 5, 7. So 1, 3, 5, 7. This is a star is coming. 1. Okay, 1 star, then 3 star, then 1, 2, 3, 4, 5 star, then 1, 2, 3, 4, 5, 6, 7. Okay, so this is the first one, the second one, this is the third one, and this is the fourth one. Okay, so this is how we have done. So these are 4 lines. So n is equal to input, enter number of rows, enter number of rows. Okay, you get it. Then outer, see, so basically you have to, outer loop will be for the rows. So I in rain 1 to here n plus 1. Okay, n plus 1, because it will not take. Now here you see we have to decrease the space every time. So if we take space is equal to here n. Okay, and then what we can do here for g in range up to space. Okay, so which is the space is the n value we can give. Okay, and then print we give the space. Okay, this is the space here, and is equal to this thing. Next we need another one for printing the star for k in range, and this time for one star we are printing for I value 1, I value 1, so j is equal to 1 to 1. If your I value is 2, then j is equal to 1 to 3. Now how to make 3? So it's basically 2 into 2 into I minus 1. This is the logic we can do. Okay, but as if you want to print, if we do 2 into I, it will become 4, so automatically it will be 3 is coming. So 2 into I, we do it here, and then we print the star and the same line, end is equal to this thing. Okay, and then we come to here, print. Okay, and let me run. Okay, this is about the print. So let me see if it is a 4. A little bit, I think there's a problem has come. Yeah, it's not coming as exactly. It's actually, if I is 1 here, so 1 into 2, so it's a 0 to 1. It should have been come here. Anyway, what is the problem? Let me check it here. N is equal to enter number of rows. I is 1 to n plus 1. Okay, that is 1 to this. Space is okay. If I see the output, what is happening here? I'm getting, oh, it's 2 and 4 it is there. So in the first case, when I is 1, j should be equal to 1. So it is getting 2. So 0 and 1 is there. So if I do minus 1, okay, let me say I think minus 1 will work instead of this. So let's see, 4. Yes, 3 and this. So alignment is bit issue. Yeah, the alignment issue can be solved very easily. I need to just put the SP value is equal to SP minus 1. Okay, this is the one which I have to do. So this is 4. So this is perfectly I can do now. One time more I run it for 7. So it is like this. So this is perfect one. Okay, this is done. A little bit you have to just see how it works. Okay, so this is done. Okay, so this much is done from my side. Like, okay, so you can see the D part. Now we come to the E part. Rewrite the code fragment. Okay, it's a bit difficult here. Let's see. You have to rewrite the code fragment using while loop. Okay, so using the while loop, you have to do this thing. So let me put it here first. So this is the one. Let me check it here how it's actually looking. Num 20. Okay, num is there. Then 20 count sum. These two lines are okay. Then we have for I is then the print I and break is there. Okay, so here we have a print I, and then after we have a break. Correct, and then we have the outside the loop. Okay, now this is the one. Let's see run and what happens. Now if we oh, there are syntax errors are there. So here outside the loop invalid character. Oh, this is just because of popping here. Okay, so let me run it here now. Yeah, 0 is it's coming 0. Okay, 0 num and 5. So num is 20. It should not be 0. Oh, it has printed 0 and then break is there. Okay, so it is coming 0 and break. That's why it's there. Now this is there. Okay, so we have understood this part. So let's see how we convert into a while. This into a while. So num is 20. That is okay. This line is remain as it is. That is okay. Now we have to initialize the I with starting value is 0. Okay, and we have to convert it. So while this I value is less than the value of num, which is num. Okay, so this num value is there. Then what we need to do is that these two values will be there. This two statement will be as it is. And remember here we have to add one more thing, which is I is equal to I plus equal to 5. Okay, once this is done, we will come to this one, which is the outside the loop. Outside the loop. Okay, and we run this one. So if we run this one, it's 0 and outside. So this is a perfect answer to this one. Okay, so we are coming to this one is the, oh, I think I need to put another one. This is, so insert a row below, and I will write this is like D, this is E. This is E, and we are getting this one. Okay, Okay, so we are coming to the question number. This is all done. Question number 5. Okay, so we are coming to question number 5, 5A. Now, what is 5A is saying you have to predict the output of this one. Okay, so predicting the output of this code. Okay, how many are there? These also there. So let me write it here first. Okay, these are there. So these are the two codes are there, and you have to find this one. So it's a very simple one. See first 1 and 3. So 1 and 3 means 0, 1, 2. 3 will not come here, so it will be ND. Okay, and the next one is 2. So the second character, which is 0, 1, 2. D is the second character plus up to second character, that is IN. Okay, so IN. So this will become DIN. Now, next one you see S1. S1 is the entire string. Oh, India they have written. So IN. Okay, right. This is working. Okay. The second one is you have S1, which is independent. And plus, you have to add with -1. -1 means up to this all entire stuff. This. So you can add it together. So you can write this thing independent INDI. Okay. And if you come to this one, which is colon 3, so 3 means 0, 1, 2, which is this one. And this 3 colon 0, 1, 2, 3. So IA. So IA. So it is coming India. Okay, it's unexpected, but it's come very nice. Okay. B part. Write a program to convert a lowercase letter to uppercase and count the string and count the number of lowercase. Okay, now this is the output should come. Lowercase to uppercase, and also you have to count the number of lowercase letter in the string. Lowercase letter and digits in the string. Okay, 2 is there, lowercase is 1, 2, 3, 4, 5, 6. Okay, what happened here? Let me see. Lowercase letter here. Oh, L is there. 1, 2, 3, 4, 5, 6, 7, 8. Okay, perfect. Okay. So let me do this one for you. It's this is something is there. Okay. So string means we take so text is equal to input, enter string, and then what we do is that for finding the each character for char in text. Okay, and we need to find the digit, which is DC, and when the lowercase lc is equal to 0. Okay, so if char is a digit, then we can write DC plus equal to 1. And next thing is that if we will find char dot is alpha is the lowercase is lower, then we write lc plus equal to 1. Okay, now let me check once program. It is saying convert lowercase letter uppercase and count the number of lowercase. Okay, so then we have to convert it also. So if the conversion business is there, so we need another string here. Okay, so let's say str is equal to str1 is equal to empty string. And what we have to, if it's a lowercase, okay, so here we need to do, if it is a lowercase, we can do one more thing, str1. Let me see, to convert the lowercase letter to the uppercase letter. So here str1 is equal to if it is a lowercase is there, so we need to convert this plus equal to char dot upper. So we add the upper version. Okay, and otherwise else, if it is anything is there, we just write str1 plus is equal to char. Okay, that's it. Okay, so this is, and we write print the str1, print the number of digits, which is DC, print number of what is the number of digits we have done, then this is number of lowercase letters. So we're still continuing this one. So lowercase it LC. Okay, so let me run it. Okay, let me. I'm using this W. Oh, it's not capital. Oh, why it's not? Oh, this is already on. W capital L capital COM 2PYTHON 3.0. Okay, so this is entire thing is becoming all the lowercase, so digits and two, it's perfect answer, so I can use this code. Okay, so this one is done. All right. Okay, so that much is quite good. Let's see, we come to the next one, which is write a program to read a sentence and reverse every word of the sentence. Okay, so let's see, we have a sentence here, and you always remember to get the words from a sentence. What you need to do, you need to use the this thing. What function you need to use? You have to use the function of split. So this will be words is equal to text dot split, and you have to, for each word you have to reverse the word. Okay, so it's saying that India is my country, you need to reverse each word. So for word in word, okay, now this is not a single word, so let's see words, and for each word we need a reverse text. Our text is equal to this thing. Okay, then we come here. What we need to do is that here we come here, and then we come to here and we write it here, reverse of the word. So rev word this 2 colon minus 1 reverse word, add it to the art text. Okay, plus equal to rev word, and I think there's a space requirement to add. You can add a space here only, and then we print the okay, text is already there, so we will art text. Okay, this one. So run it. So India is my country. Okay, so if you run it here, oh, it's working fine. So this is the output. Okay. Okay, so there was a bit of a issue. Now I'm coming to this is the C, now the D. Okay, so D is what is the D? D is saying input store all the even number in the first half and all the odd numbers in a second half of a new list. So it's a very simple one. You take a list. Okay, list is equal to even, and then you write input. Okay, enter values and values. Then you take another list. Okay, let's see, m is equal to this one. Then you read the values x in list. In this list, if okay, first you have to store all the even numbers to find x mod 2 is equal to 0. So you need to just okay, so what we need to do, if it's a even number, so it's a my list dot append, and we give the x. If this is done for the even number, then again you need to do the same thing. Okay, this time what you will do is for the odd numbers, and you will append. Okay, then finally you print the my list. Okay, so if I run this one, what I will get it here, enter value, let's see, 1 comma 2 comma 3 comma 4 comma 5 and 7 comma 8. Okay, so this, if I see, you see 246, all the even number has come and followed by all the odd numbers. Okay, so this is a bit of twice effort, but it's a simple one. Okay, so we have done the D part. Okay, now we come to the question number 6. Okay, now this is the one, question number 6 I will do. 6. Okay, now 6a. Now what is 6a is saying is that okay, this is, oh, what does this return? Okay, they are saying what does this return. So I'm just copying. This is a very simple one, I don't need to tell. Now if I do this one, you are getting, if I print L colon minus 1, so it is going to return the values in the, so it will return a list, it will return uh, the return a list, uh, copy of list with elements in reverse order. So this one is done. So we come to the B1. B1 is that determine the output of this one. Okay, so this is let me put it here if it works. So this is, this part is there, then this is this and this one. So here you see this D is basically all the keys. K is the key in present. So A, B, C. So your 3 plus 2 is 5, 5 plus 4 is 9. So it is adding all this. So the answer is should be okay. It's printing. Oh, sorry, it's a bit of print. So it is making a list and it is showing here. So don't be careful. It's not asking for the sum here. So oh, there is print D. So it is not since output is there. So you get confused a little bit. So it should have been sum also. That should have made more sense. But anyhow, sum is 9, and actually this is the output. Okay. Now we come to the C part. C part. Okay. Now C part, what it is saying. C part is write a program to input two tuples and you have to find the union of two tuples. Union of two tuples. These are the two tuples and you have to find the. So you come. Okay, I'm showing it here how to do this one. Okay, now this is the one. So we are getting this one. So union. Okay, so take a tuple T1. So I'm taking this tuple only. Okay, let's see. I don't want to this one, and my tuple T2 is equal to this one. Okay, I've taken this one tuple. All right. Now and this tuple is the union one. So what I will do is that first I will take the value from for x in T1. If I say if x not in T, okay, it's not already there, then you write that T plus equal to, remember to put a value of x, you will write this syntax. Okay, that is done for the T1. Now the same thing you will do for the next T2. Say if it is not there in this T2, and you can take all the values of there, means even you make a shorter code. Okay, like T is equal to plus equal to T1. So you don't need it actually the second. Then you write the x is T2, and then finally you write the print of T. Okay, so we can okay, let's see, we run it here. Okay, you see 10, 30, 50, 60, and here 10, 20, 40, 50, 60, 70. So the order is a bit changed here. 10, 20. If you want to print in a different order, that you can do it, but it's not a union. So 10 is there, 20 is there, 30, 40, 50, 60, 70, everything is there. So it's perfectly correct. Okay. So we have come to here. Okay. So this is also done. Okay. So next is our question number output. Okay. Output of this one. So this is the output question. I'm putting it here. So see, when you append this one, so you should get here this entire thing is there, will be printed as it is, followed by a 10. And then you print this thing. So obviously it is going to print this thing. Then it is saying next thing is that you have at the second location you have to insert 4. So 0, 1, 2. So this location 4 will come and 6 will be there. Then he is saying to pop a value. Pop a value means the last value will be removed. So we pop this thing. So we get here this 10 is removed. So it is going to, so one output will be this. Okay, one time it is going to print the entire thing, and one time with this part is there. So this is the one line output, 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 and this is another line of output. So if we run it here, okay, so this is 2, 4, 4, 6, 8, 8, 9, 3, 5. You can see this is the first time is all this there, and second time 2, 4, 4, 6, 8, and here. So this is the output is there. I think you have understood why this output is so. Okay, so this is the C. So your D is, okay. So these are the two lines of output, and then we come to the, okay. I see. Oh, this is the list one, so that's fine. Write a program to create a dictionary and check if the keys of the dictionaries are string or integer. So you have to check whether a key is a string or a integer. So what you can do is that you take okay, a little bit, you need to, it's very simple one. You take a dictionary, okay. So like a dictionary is a flexible one. So it's an integer dictionary. So you can take a dictionary like this, then no, or you can take a dictionary from the user. Okay, all right. I think this is to be removed. D is equal to eval, and you okay, input, enter dictionary, enter dictionary. Okay, and then we come to here. We see here. Okay, so for each, what we need to do is that we have to see whether it's a number, integer, or a string. So for key in D, which is each is of the dictionary. Now, if key, okay, we need to see whether it's integer. So key, okay, now key, we can see if the value of key is a string. Now, so to understand that it is the string, uh, can we see the type of this one? If the we can is we need to see the, okay, okay, dot is alpha. If we do is alpha, that means print key is string. And if we go for the next one, if key dot if it is not an alphabet and is digit, okay, it's digit. Okay, so that means the entire thing is digit. Then we can say print uh, key is digit. Okay, it's a number. Okay, integer. Okay, let's see. All right, so let's we come here. Okay, let's see. We run this one a bit. Oh, there is some invalid syntax. Oh, this colon has come. So let me run it here. So enter dictionary. So we write here 1 colon 10 e colon 20, then 3 colon 30. Okay, and lastly d colon 40. So this is what we have done. Uh, so attribute e. Okay, so int has no attribute is alpha. Okay. Uh, this is k for the first. It is a, so it's not working like this way because we need to check this is a string or not. Okay, so if it is a, because we have to make it is a, oh, that thing what we can do is that we take this is a k is equal to str of k. Okay, so this is, now if we see this sk is this one and k is this one, then we can run it. Okay, let's see. We one time more. then 1 colon e colon 20, then 2 colon 20, 30, let's say. So this is one is integer, two is integer, and a is string. So this can work for this one. So I think this is good enough. A little bit trickier than otherwise. Okay. Now what see the question number this Internet of the Things function of cookies. This is bit of theoretical. I think you can manage on your own. All right. So to all of you, best of luck for and go through these things. Okay. Internet of Things. You know all the basically IoT is device where all the devices can be connected and they can become smart devices. Okay. They can be like your Alexa and all Google devices which can do phishing. You know it's a way by which these things are done. Okay. So functions of cookies and all this virus, this all I think you can easily manage. Okay, so once again, to all of you, you all, I'm assuming you all should do better for this exam. All right, so here we end the session. Okay, so we are ending this one. Okay, so best of luck to all of you for your exam.